Hi, in this part, I'll explain the process of integer multiplication based on the pseudocode on Booth algorithm in which I will display right here. We begin by putting two numbers, the multiplicand labeled as m and the multiplier labeled as q. Next, we calculate how many bits are needed to represent both values in binary. Then, we initialize a few variables. A is set to 0, Q holds the multiplier, Q1 is set to 0, and we calculate the 2's complement of m. Now the process begins, which repeats for n steps, which is n stands for the number of bits. In each step, we check the last bit of Q, which is Q0 and Q1. If Q0 is 0 and Q1 is 1, we perform A equals to A plus M. If Q0 is 1 and Q1 is 0, we do A equals to A minus M. If both bits are equal, we do nothing. After that, we display the step details and then perform right shift on the combination of A, Q, and Q1. We then increment the step and repeat the process until all steps are done. At the end, we combine A and Q to get the final binary product, which then convert to decimal. That's all. Thanks for watching.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Daniel Ashraf. So today I will show you the flowcharts about the integer, arithmetic, the multiplication method. First of all, before we jump into the Java program, we need to plan our flowchart from start to finish and how it will be running. So these flowcharts make the flow of our program will be more smoother and easygoing. So it will begin from we're going to take input from the user to enter the multiplicand and multiplier, and then the process will calculate the bits needed for M and Q. It will also initialize A equal to 0, Q equal to multiplier, and lastly Q1 is equal to 0, and then it will calculate the neglected m, which is we make a new variable named neg m, and we make it into two complements of m. That is required steps. If yes, then the program will go into more selection. It will divide it by 3 segments, which is 3 conditions also. It will check whether the Q0 and Q1 bits, if Q0 equal to 0 and Q1 equal to 1, it will make the calculation into A equal to A plus M. Other than that, if the output will be going to be the Q0 equal to 1 and Q1 equal to 0, it going to be A equal to A minus to the M. However, if it other than the condition that we provided, it will be no operations. So with these 3 conditions, all of it will be displayed. The steps, detail, and arithmetic will shift right on A, Q, and Q1. Lastly, it will increase the increment of the steps and back to the loop, which is if there is no more steps or else. If there is no more steps, and it will combine A and Q for the final product, display products in binary, and also display the decimal into the equivalence digit. So lastly, then the program will end the process and end the program.
Assalamualaikum warahmatullahi wabarakatuh. So this is our program. So this program is a Booth algorithm program using Java as our coding language. So now I will explain the code easier so that everyone can understand. So first we will look at the program overview. So in this Java program, first we read 2 integers from the user, the multiplicand M and the multiplier Q. Next, you will figure out how many bits are needed to represent this number, including the sign bit. Next, it will use register A, Q, and extra bit Q-1 to perform the multiplication. Next, it will run the algorithm step by step, showing you the internal state at each cycle. finally, it will output the product in binary and decimal. So first step, step 1, it will get input. We start by importing scanner and asking the user to enter two integer. So as we see, this line of code start from this, and here it will ask the user to enter the multiplicand and multiplier. Then it will store into the system. Next, step 2, calculating bit width. So we need to know how many bits to use. So we calculate the minimum bits for each input, including the sign bit, then pick the large number. So this is the line of code that involved. So it will determine minimum bit needed. So for your information, this program can handle until 16 bit. Step 3, initialize register. The algorithm uses 3 main register: A accumulator, Q multiplier, Q -1 previous bit. So if you look at the code, we will initialize the integer. So A will equal to 0, Q equals to Q, and Q -1 equal to 0, and also integer mass and integer -m. So this is to convert to 2 complement. Step 4, running both algorithm loop. For each of the n step, first we will check the last bit of Q, Q0, and the bit Q -1. Then we will decide the operation. If Q0 equal to 0 and Q -1 equals to 1, we will add m to A. Otherwise, if Q0 equals to 1 and Q -1 equal to 0, we subtract m from A. Otherwise, there will be no operation. Then we will print the current step, values of A, Q, and Q -1, and what operation was performed. Then we will combine the register into one number and perform an arithmetic right shift. Then we will extract the new values of A, Q, and Q -1. Let's look at the code. So this is the loop that perform the step 4 of running both algorithm loop. So if you so this is the first scenario, second scenario, and third scenario, which is no operation. Then it will print. Then it will do arithmetic right shift. So let's look at the next step. So step 5, final product and output. Once the loop ends, we combine A and Q to form the full product and convert it back to decimal, considering 2's complement if needed. This is the line of product decimal equivalent. Also, we also account for two complement. And additional information, we also use 3 function. First one is the minimum bit for sign function, and the second one to binary string and arithmetic right shift. And this is all important in order to make the code function. So why is the combine shift important? So this line is very important because it combines A, Q, and Q -1 into a single number to shift all bit together. Exactly how we do it. So when we run the code after this, it will show why this line integer combine is important. So that's all for the code explanation. Thank you.
Alright, Assalamualaikum warahmatullahi wabarakatuh. Thank you for Nazir for explaining the code. I'm Hamza. I'm here to show you how the punch program works. So first, let me run the Java. First, you can see it for me to enter the multiplicand. I will enter 2, and for me to enter the multiplier, I will enter also 2 because it's easier. So you can see what is the output. It gives me the steps, A, the Q -1, and the operation needed. Side note, the product in binary, it technically from step 4, it pretty much makes give arithmetic ratio, which is why it's a bit different, but yes, it's still correct. As you can see here, from the last 4 digits in the binary, it pretty much gives 0100, which is decimal equivalent for 4, which means it is correct. You can see here the steps corresponds to the number of bit size, as well as the A and the Q, it correspond with the bit size. Why is that? It's because of this line of code. This line of code makes it so that it always corresponds with the bit size. And the minimum is 4, the maximum is 16. So if it is more than 16, the program will have error in it. Next, I run again, and I will put a negative number. For clarity, the multiplicand is the one that needs to be a negative number, and the multiplier is the one that needs to be a positive number, or else the program cannot run. So we look at the output. We see the steps, the A and the Q, and we just look at the product in binary. We can see here it is this number. So we're going to convert it into two complements, so we can see the real output. So the two complements just convert 1 to 0 and 0 to 1. So the last 4 digits should be 0 1 1 0, which is supposed to be the two complements, and it pretty much convert it to 6, and it is correct. Why? Because there's the one here at the front, so they pretty much symbolize the negative number here. So that's pretty much it. However, I will run it again, and I will show the capability of the program. Let's try 3000, and we'll try 7. As you can see, the decimal equivalent for 3000 times 7 is correct. And then we see the steps and also the A and the Q. As one can see, the number of bits correspond with the integer entered. So, and also the same with the steps, it is all the right steps. So the program is pretty much made it so that it is always corresponding with the bit size. So it is always compact, and there's no extra digits that is needed. So that is all from us. This is our program, the Booth algorithm calculator. So yeah, thank you. Goodbye.